Welcome to GMAETS 41's YouTube channel, your channel of excellence. I want to believe that by now you've enjoyed question number 10 of our product U-Substitution part B. In this short lecture video, I'm going to solve this problem for you, adopting our Omaka's product U-Substitution principle. We are given this integral to evaluate. It's a finite integral. That's why we have this limit. Now, if you look at this term given to us, this integral is a product of two functions, right? We have x multiplied by x squared minus 5 all to the power of 3. 8 is a constant. Normally, it will come out of the integral sign, before you start integrating. Now, all I have to do is to quickly check if I differentiate one of the term, will I get the other one? If you differentiate this term, let's see, differentiate with respect to x, this x squared minus 5 all raised to power 3. This is what you're going to get. Do your major minor derivative. If you are lacking in any way in understanding concepts of differentiation and integration, remember, on this channel, I have provided super works on calculus. You can click on this link, all right, this info link, and it will take you directly to the GMAETS 41's Mark 101/Mark 102 playlist, where you can find video lessons on differentiation and integration. Take your standard derivative, take your standard integrals. You need them, I've always said that, to guide you through the principles of calculus. If you differentiate this term, what you're going to get is 3 times this bracket raised to power 2, then multiply by, you differentiate the minor function x squared minus 5, which will simply give you 2x. Now you observe that this derivative produced x here. That x is the second function you have here multiplying this function given in the problem. The fact that you have this variable here, this function in the question, you have it produced here. It simply means that product U-Substitution will solve this problem. However, the product U-Substitution principle we use here will not be that which you saw in question 6 to 9. The reason is that when we differentiated this term, look at it, still produced a variable for us. It produced a variable. It gave us this function, no argument. Look at it. We have it. It gave us constants as a difference. So we have this constant 2. Here, the constant here is 8. But the constant is not the only thing produced in this derivative. It still came along with a variable. For that reason, the principle we used in question 6 to 9 won't solve this. Rather, you apply the technique I introduced you to in question number 10, where I brought in the concept of Omaka's product U-Substitution principle. Reason, because there is a variable that came out also. Apart from the fact that we obtained this function here in the derivative still came with another variable that made a whole lot of difference from the original thing we had in the question. So in this case, what we have to do, applying the Omaka's principle, we are going to keep this 8x constant, and then we shall integrate this term, which you differentiated to produce this x, okay? All right, so let us integrate this and see what we are going to get. Integral of this term is simply for you to add 1 to the power, divide by the power, and then differentiate the minor function in the denominator. Do you get that? So that is going to give us equal to 8x. If I integrate this, I'm going to add 1 to it, which is x squared minus 5. Add 1 to power 3, you get power 4. Divide by that power 4. Then move on and differentiate this x squared minus 5. If you differentiate x squared minus 5, you're going to get 2x. This is 0 already, it will go off. Now, I will not put plus c, plus k, constant of integration. I won't do that here. The reason is because this problem given to us is a finite integral. It has limits. So the first thing here is do your normal integration, but don't put plus c, plus constant of integration. No. We are going to apply our limit. So I'm going to close this in a square bracket. Then the limit is from 0 to 1. So at this point, what we now have to do is to simplify what we have inside. this square bracket, and then apply the limit. In the denominator, we'll have 4 times 2x, which will give us 8x. So you see that this denominator will cancel this completely. I said this when I introduced the Omak's product U-Substitution principle in question number 10. That by the time you do, that test, integrate now that function that produced the other, that something is going to cancel out. You can see that there. All right. So at this point, what do we have? Observe that we now have this x squared minus 5, all raised to power 4. We shall now apply our limit there. So let me write it out for you still. Then the limit 0 to 1. Let us apply the limit and see what we're going to get. This will now be equal to, what do you do with the limit? Start with the upper limit first. Wherever you see x, what you integrated with respect to, fix that upper limit. So here, this is x squared. I'm going to remove the x squared. I'll fix this 1. If you fix that 1, I'm going to remove the x and fix the upper limit 1. So I'm going to get 1. The x is squared. So that 1 will also be squared. Then minus, if I let me enclose this in a bracket, minus, substitute lower limit, which is going to be 0. You square it. You get that? This one is a waste of time working with 0. Take notes. That's because I want you to see this clearly. That's why. Now, substitute upper limit minus lower limit for this x. Look at it. The next term you see is minus 5. This is just a pure number, so you write it minus 5. Now, you notice that all of this term is raised to power 4. All of this term is raised to power 4. So I'm going to enclose all this in bracket and then raise it to power what? Power 4. Look at, substitute the limit, then you simplify. The bracket is raised to power 4. So when I fix the limit for x, upper limit minus lower limit, whatever affects that variable you are substituting the limit for must affect the limit you are also fixing. Are you following, right? Then at the end, outside the bracket here, you have power 4. So you write that power 4. Let's simplify this and see. This is 1 minus 0. You have 1 minus 5. You have minus 4. So this is minus 4 all raised to power what? 4. I have to take my time to show you all the workings here because in our super shortcut approach, this is our first, finite integral problem. So I just want you to see how you handle it fully, okay? So the integral given to us, which is this, will now be equal to minus 4 all raised to power 4 will give you 16 times 16. The power is even number, so this negative will disappear. Are you following? So you just simply have 4 raised to power 4, which is 16 times 16. 16 times 16 is going to give you 256. And of course, this is the integral of the problem given to us. You can see how simple we obtained it. Now, my interest in this question is not how you apply the limits. That one is not a problem. We have a unique video lesson on this channel that covers, finite integral. How I integrated this is the most important thing I want you to learn, which is keep this function constant, then integrate this. Simplify whatever you have there. Are you following right? That's the main thing that you've really learned from this lecture video. I hope you enjoyed this. Of course, I've given you further knowledge on how to apply your limit of integration. I'll be seeing you in the next video lesson. If you're yet to subscribe to this channel, click on the subscription icon, turn on your notification bell, select all so that once I upload any content, you will be personally notified by YouTube. Remember, to subscribe is free of charge. Turning on notification bell is free of charge. So feel free to do that, okay? However, to get more benefit from this channel, consider becoming a channel member. I'm appealing to you to join the channel, become a member of this channel so you get access to members-only video with many more benefits. You can join the GMAETS 41 on platinum level, which goes for 2,000 Naira per month, or on diamond level, which goes for 4,000 Naira per month. Remember, the higher the level you join this channel, the more benefits you get. If you join on the diamond level, please quickly contact GMAETS 41 on this contact you have with this number, all right? because there's still further benefit that is attached to joining the diamond level. I'll be seeing you in question number 12.